Hello and welcome to a new video. This is Pre-Algebra with Math UC. We are on lesson 14, which is about solving for an unknown with order of operations. So this should be fun. We've done some equation solving and we've kind of touched on order of operations. It's an ongoing thing we talk about in math. Once we get past, knowing how to add and multiply, then we have to go, okay, which one do we do first if they're together? So hopefully some of this is review, but even if it's not, I think we'll all get there. So let's go ahead and try. Let's get started with order of operations. This is one of those cases where whoever came up with this, I don't even know, but it has just become a thing in math education that just in general everyone seems to use. And I don't know who came up with it. I don't know how long it's been around, but we have this thing where the order we do operations matter when they're mixed together because we want to be able to get the same answer no matter what's going on in the problem, right? That's the thing I like about math is there's one answer most of the time, not a bunch of answers. So we have an acronym here to help us with remembering how to do the order of operations. So it's fondly known as PEMDAS, which is a fun made-up word. Lots of people just use the word itself, PEMDAS, but there is a phrase that goes with it as well, which is please, for P, excuse my dear Aunt Sally. Again, I don't know who came up with this. If you wanted to, you could come up with an acronym that you might like better, but this is what we've got to go with. And in fact, in the Math UC workbook, they use something slightly different. They use, instead of please excuse, they use parachuting expert or parachute expert or something like that. And it's the same thing because no matter how you look at it, we are supposed to do P first, which is going to stand for parentheses. Hopefully that's how you spell it. We do parentheses first because parentheses, the whole point of parentheses is to draw our attention to what's happening and to say, hey, do this first. Really, the only reason we have this whole order of operations issue is because putting parentheses in takes more work. And so there's a lot of times where we can make things clearer just by putting in more parentheses. And in fact, that's something we can do when we have a calculator to make sure it's doing what we want it to do, is we can put parentheses around things to make sure it knows to do that first. But parentheses and anything else that groups things together, that's supposed to happen first. Then after that, we look for E, which stands for exponents. So squared, cubed, and so on, fourth power, fifth power, all that jazz. Those come next. So if you have a 2 squared, that's going to happen before you add or subtract numbers. And that's because we're going to talk kind of about closeness, kind of like I've talked about with solving equations and how to decide what to do with solving equations. We want to think about how close the operations are to the number and what is being affected by things like exponents so that we know what order to do it in. The next part of this can be tricky. So we're supposed to do these in order, parentheses first, then exponents, but multiplication and division are actually on the same level, that you do them from left to right. And so this is really an issue of if all you have is multiplication and division, you just want to do it from left to right. This is actually an annoying topic for me personally because really at this point and further on in math, instead of using a division symbol, we should really be writing it as fractions because it clears up a lot of the issues that we might have on order of operations. And also this is where you'll see on social media these problems that people are like, what answer did you get? And everybody can get different answers using different order of operations. And it's like mathematicians also will argue between a couple of the answers because it's clear that it was intended to be solved one way, but the order of operations we teach in grade school give you a different answer. So really I think that we all just need to use parentheses whenever things like this are unsure, or fractions would be even better. Sorry to rant, but it's kind of a pet peeve of mine. And then adding and subtracting also happens on the same level from left to right. If this is your first time seeing this acronym, then you'll want to definitely pay close attention. Even if you've seen it before, I should have put addition and subtraction since I put multiplication and division, but whoops. Even if you've seen it before, please pay attention to, like, I'm going to think out loud for you on how we kind of go through and decide what to do. And what's important is that you are able to kind of internalize why these things work the way they do, so that when you see a new problem that looks a little bit different than the one we did, you'll go, okay, I now know that I need to do this first and do it, and then I need to do this and then do it. So you got to kind of like make these rules a part of how you think about math in order for it to make sense. Some of these end up being pretty complicated, so also know that it's okay if you don't get them right on the first try. Just keep trying, keep plugging away, ask questions if you've got them, and we'll just all hope for the best. Example 1. So simplify each expression using PEMDAS. Again, the Math UC workbook says parachuting expert, my dear Aunt Sally, or something like that. Whatever, it's fine. Well, let's look at these. So part A, we've got 2 times 3 plus 4 times 5. So for PEMDAS, we look for parentheses, there aren't any. We look for exponents, there are not any. Remember, those are the little numbers up and to the right. We look for multiplication and division. We've got 2 sets of multiplication here. So really, what would have made this perhaps a lot clearer would have been for whoever wrote the problem to put parentheses around it. But what we've done as math people who are lazy, we've said, we don't need those parentheses because we know the multiplication should happen first. That's kind of the idea of why there's not parentheses around them. So we need to do 2 times 3, which is 6. We need to do 4 times 5, which is 20. And then we keep the plus sign that's in between. And now we just have 6 plus 20, which we can do and get 26. So that would be our answer. Okay? So that's kind of the process we go through. We say, okay, we've got multiplication, that needs to happen before addition. So doing 3 plus 4 was not the correct way to go there. Let's look at B. 1 plus 12 divided by 4 minus 2. So we've got addition, division, and subtraction. So we got to think, what is supposed to come first? Well, division is supposed to happen before addition or subtraction. So we should be doing 12 divided by 4, which is 3. Then we drop everything else down. We've got 1 plus, and then we've got minus 2. And now we're going to do 1 plus 3 minus 2. And since it's addition and subtraction, we can do that just from left to right. What that means is we do 1 plus 3 and get 4. And then we do 4 minus 2, which gives us 2. That should be our answer. When it says to do addition and subtraction from left to right, it's trying to prevent you from like somehow messing up the signs. If you think of this line instead as 1 plus 3 plus negative 2, you actually can do this in whatever order you want to, because now it's all addition. So it has to do with how we think about subtraction. If the shakier we are on subtraction, basically, especially once we have positives and negatives, the more we need to just do from left to right until we feel more comfortable. So these started off pretty simple. We're going to make it more complicated. Let's see what happens with that. Example 2, same instructions, but they're a little bit more complicated. All right, on A, look at that 3 there, that exponent. That needs to happen first. So this third power is only affecting the 4. And I know that because if it was trying to affect anything else, we'd have to have parentheses. So this problem does not have 3 plus 4 in parentheses to the third power. So that's why 3 is not being raised to the third power as well. That's kind of an important distinction I want to make here. So what we need to do is 4 to the third power, which is 4 times 4 times 4. Those first two 4s are 16, then times it by 4 again and get 64. So make sure you don't just say this is 12, because that's 4 times 3, not 4 to the third power. So this part goes away and turns into 64. Everything else is going to continue as is, and then we'll go, okay, we did exponents, what's next? Multiplication or division? We do have division here in the middle, 64 divided by 2. We might need to come over here to the side and do some long division for that, and that's okay. We get 32, so we'll make that change. 3 plus 32 is 35, and then we're going to subtract 6 and get 29. This is, again, one of those times where you should try really hard to show your work. If all you write down is the answer, if it's wrong, your teacher will not know how you got it wrong and won't know how to help you. If it's right, then it still looks a bit iffy, because it's like, well, how did you do it? Like, did you luck into getting it right? Did you use a calculator or look at the solutions to get it right? Or did you do it yourself? So keep that in mind, that if your teacher is like, show your work, show your work, show your work, they actually want to know that you know how to do it, which is what teachers are supposed to do. So yeah. Okay, anyway, B. All right, we've got parentheses. So normally, if these parentheses weren't here, then our multiplication would happen first. But because they're there, they're telling us, no, I want you to do 3 plus 4, which is 7. I want you to do 8 minus 6, which is 2, and then multiply. So that's where parentheses are really helpful, is if basically it changes the order we do things in, right? From what would happen if they weren't there. 7 times 2 is 14. So that's our answer. Okay? Again, I'm trying to think out loud with you, so that hopefully you have the right reasons for what we're choosing to do first, and so on. But some of these can be kind of complicated, and especially if you're on one that's complicated and aren't sure what to do, definitely ask questions or look at a solution manual and see if you can figure out, why they do what they do. So, example 3. So these are a little bit more complicated again. Both of these have parentheses, so that's kind of makes it turn into almost two problems, because when I look at the parentheses, I also have two different operations inside my parentheses. So if I'm going to figure out 2 squared minus 1, I need to think, what do I do first, this exponent or subtraction? Well, I'm going to do the exponent first. So 2 squared is 2 times 2, which is 4. Then I subtract 1 and get 3. So that's what's going to go here, is a 3. Okay, but then I have to start over and say, okay, I got rid of parentheses, what's next? Exponents. So even though I did the exponent inside the parentheses, I still need to do the exponent here on 11 as well. Be careful until you're really feeling confident about this, about doing things at the same time, because sometimes we can rewrite this as a new step and maybe do multiple things at the same time, but we don't want to accidentally do something that it's too early to do. I don't know that made sense. I'm sorry. 11 squared is 11 times 11, which is 121. So that's 121 minus 3 times 6. Now 3 times 6 needs to happen before the subtraction, because multiplication comes before subtraction. So 121 minus 18. That might be easier to come out to the side and subtract like this, because we got to borrow. Looks like that's 103. Now also keep in mind that if you're making little mistakes like with multiplication, addition, or subtraction, but you're doing the right order, then that's better than if you're doing the wrong order completely. Like if you did 121 minus 18 and said it was 102, and then you still did the correct order of operations. You just need to be more careful about your mental math you're doing, or written out math you're doing, or whatever it is. Okay, we've got parentheses on B again, so we need to look just at this part on the inside and figure out what to do. So 9 minus 2 times 3. Well, 2 times 3, we can actually think of this two different ways, by the way. We can either think 2 times 3, which is 6, and then drop down the negative, or you can think of it as negative 2 times positive 3, which also gives you -6. Both ways, we should end up doing 9 minus 6, which is 3. So this parentheses, the inside gets replaced with 3, but we still have this squared here. So 3 squared plus 5 squared. Now we do exponents before we do addition. So I'm going to do 3 squared, which is 3 times 3, which is 9. 5 squared, which is 5 times 5, which is 25. And then I'm going to do 9 plus 25, which is 34. So that should be my answer. So lots of things happening here. So definitely something that you'll need to practice and get used to. And definitely check your answers and use a solution manual to help you figure out where your mistakes are. Now, aside from just straight up order of operations problems, we're also going to do some more equation solving that involve order of operations. The tough thing about combining those two things is that the order of operations that we know, PEMDAS, is true on either side of what we're doing. So looking at the left side of this equation, there are things I can do with PEMDAS to simplify it, and the same thing on the right. But once we get to the point where we just have like a number and an x on each side, then we kind of switch our order of operations to solve, right? So let's take a look at how that works. Let's first start here just by looking at the left side and what we can possibly do to simplify on just the left. So we've got parentheses. You can distributive property this, by the way, and you should get the same thing as if we say, I'm going to do the parentheses first and get 3 and then times it by 2. I'm going to switch to a dot since we've now got x's. And nothing we did here with this parentheses affected our 2x because it's just kind of off to the side, plus 2x. But we can do 2 times 3 also. That gives us 6 plus 2x. And now this looks like something we're used to having on one side or the other of an equation. Now let's look at the right side. We've got 3 squared minus 1. So we do exponents before subtraction. So that side should end up being 9 minus 1, which is 8. So I'll just bring that 8 down here. So this is what I'm talking about, how now our order of operations feel like they change because we don't mess with the 2 that's being multiplied with x first. We actually mess with the 6 because now that we've simplified as much as we can, now our goal is to undo what's happening to x, and so we have to work kind of from the outside to the inside. So that 6 needs to be subtracted over first, and then we take care of the 2 that's right in front of x. It can be confusing, so that's one of the reasons why we practice. That's why we look at examples together. This should be 2x equals 2. And now we either just think about the answer or divide both sides by 2, whichever one you're more comfortable with. And we get x equals 1. Oh, it does say to check our answer. And this can be a bit annoying because a lot of this we've just done. So if we did it wrong the first time, why would we notice and do it right the second time, right? So like the 2 times 4 minus 1, we figured that out as being 6. Now this is new. 2 times 1 is 2. We already did 3 squared was 9 minus 1. Does look like we get 8 equals 8, so I think we got it right. Good job us. Let's look at one more of these on example 5. So here we've got some parentheses. Now this is an interesting thing. We've got parentheses here that don't actually matter because there's not anything in front to distribute. 5 plus x is not something we can actually add together. Don't think of that as 5x because that would be if we were multiplying them. But we're adding them. So this actually just needs the parentheses to go away. That was kind of a way to maybe trip us up. So how dare they try to trip us up? All right, but we do need to do this 4 times 5. Again, in some ways, though, this parentheses was not necessary because we should have done 4 times 5 before subtracting anyway because it's multiplication. But anyway, that changes to minus 20. And then we've gotten rid of all our parentheses. How about exponents? There aren't any exponents, so no need to do exponents. Multiplication. The only multiplication we have is the 2x, which there's nothing else we can do with that yet. So then we're doing addition and subtraction, and this is where on the left side we have to think about like terms because we have a mixture of numbers and x's. So we need to do the 5 and the negative 20 together and get negative 15, and the x and the 2x together, which gives us 3x. On the right side, we have like terms also. 16 minus 2 is 14.
Hello, darkness, my old friend.
And I messed this up because I was trying to make this equation work out nicely, but I don't think that's going to happen here. Because if I add 15 to both sides, I get 29, which is not divisible by 3. Now fractions happen. When I divide this by 3 on both sides, and it doesn't go in, you know what that means my answer is? 29/3. Or we could make it a mixed number. So 3 into 29 goes 9 times with 2 left over, so that'd be 9 2/3. That would be unpleasant to check, and in fact I say let's not do it, but that's the idea there of how it would work. I'm gonna double check. I think I did everything right. So just something I did in my head when I wrote the problem was not correct because I thought we were going to get something nice like 5 or something. Oh well. Thanks for watching. I hope you enjoyed the video, or at least enjoyed it more than you would have enjoyed watching someone else's video. If you liked it, please leave a like. That's the thumbs up button that you see under the video. If you don't want to like it because of the math, like it because of me and my Star Wars Christmas sweater. Not an ugly Christmas sweater because it's really good looking, but like it for my Star Wars sweater. And for me, this is happening right before we go on break, so I'll see you in the next video, but perhaps that will be after you've had a break. So enjoy,